Hi everyone. For today's lesson, we're going to focus on isotopes mostly. And for this lesson, we're going to learn about the average atomic mass. So if you go into your notes packet and go to the bottom of page 7, you'll see a part about writing in the definition for average atomic mass. If at any point during this video you need to slow down, pause, or rewind, feel free to do so. All right, now that you're at the bottom of page 7, go ahead and write in your definition for what average atomic mass is. Average atomic mass is the weighted average of all the isotopes for an element. Okay, so when we're talking about isotopes, one clear example would be something like C12 and C13. So these are two possible isotopes for carbon. Carbon with a mass of 12 and carbon with a mass of 13. What makes them the same is that they are both carbon. So therefore, both of them would have 6 protons. And that's how we identify them as carbon. Now, because their masses are different, their nucleus has to have one particle that changes. And what's going to change is their number of neutrons. So for carbon-12, their neutrons are going to be 6. And for carbon-13, their neutrons are going to be 7. Okay, so that shows you the difference between their masses. Okay, on the periodic table, and in fact, this is a really great resource. If you go to ptable.com, it gives you a really great periodic table with a whole bunch of information. But at the top here, if you click isotopes, you can click on any element and see all the different variations of the isotopes for that element. So carbon, you can see that it goes from a mass of 6 all the way to mass of 20. It's got all these variety of isotopes that are possible. Now, some of these isotopes might only exist like 0.01% of the time, so it's a very, very minuscule amount. The more stable ones are going to be like carbon-12, 13, and 14. Okay. If you look at carbon-12, you'll notice that it has a black box around it, meaning that it's stable. What that means is that the proportion of protons to neutrons is stable enough that it's going to hold together and it's not going to decay into simpler substances. Some of these heavier carbons, like carbons 15, 16, 17, those ones do decay. In fact, those ones specifically do beta decay, which we'll talk about later. But what that really means is that in their nucleus, the ratio between how many protons they have and how many neutrons they have is just not balanced, and it doesn't hold together very well. So because of that, it wants to decay into other substances. Okay. Now, if we look at our periodic table, here on the periodic table, we can see that carbon has an atomic mass of 12.0111. Now, many of you probably thinking, well, how do we have a 0.0111 of a proton or of a neutron? Because that mass should represent total protons and total neutrons. Well, how do you get 0.0111 of a proton or a neutron? Well, you don't. What that number on the periodic table actually represents is using all these different possible isotopes and how much they occur in nature to calculate that average atomic mass. Now, the way they do that, if we go back to our notes, is with this equation that you need to copy down. Okay, so they take the mass of the isotope, they multiply it by the abundance, which is typically given to you as a percentage, they divide it by 100, and then they add it to the next isotope, and so on and so on. So a couple things that I want to point out to you is in this equation, first of all, there's this dot, dot, dot. So this dot, dot, dot means it keeps going and going and going. So you can do this as many times as you need to. So this part right here represents isotope number 1. This part here represents isotope number 2. Okay, if you add a third one and a fourth one, you could add other parts to it. Okay, couple other things I want to point out to you before we use this. One, you're going to multiply the mass and the abundance. So make sure you understand that's a multiplication. Between the two different isotopes, there's an addition sign. So you'll multiply the mass times abundance, divided by 100, but then you're going to add it to the next set of mass times abundance, divided by 100. Okay? And if there's a third isotope, you'll do the third isotope, and you'll just keep going on. Okay? All right, so let's just jump into a problem here, and you can see how this is going to work out. Okay, so here we have example 1, which should be the same in your notes, and it's asking what is the average atomic mass of lithium if 7.42% exists as this lithium with a 6/3 and 92.58% exists as this 7/3 lithium. Okay, so first of all, let's talk about what this means as a quick review. So if we have that 6/3 in your lithium, hopefully you remember from your notes that this is called isotope notation. That top number represents the mass of the isotope. That bottom number represents your number of protons, which sometimes they leave off the bottom number because if you have the symbol, you can look on the periodic table and find the number of protons. So the top number will always be given to you. The bottom number sometimes is left blank. Okay? All right, so now that we know what this information means, we can actually put it together and use it in our average atomic mass formula. Okay? So if we read the question carefully, the first isotope they give us is actually that lithium-6, the lithium with the mass of 6. The abundance for it is the 7.42%. So we're going to use the first mass they give us, which is 6. We're going to multiply it by that abundance that's associated with that mass, so the 7.42. We're going to divide the entire thing by 100. Okay, so that's your first setup for the first isotope. Now, since we are given a second isotope, we're going to add that setup to the next one. So the next one, we notice that the number on top was a 7, so that's our mass, 7. We're going to multiply that by the 92.58, which is the abundance percentage, divided by 100, and that's it. Because we only have 2 isotopes, we'll be able to hit equal on our calculator, and we can get our answer. What is really nice about this formula is the way it's kind of written out is the way you'll put it in your calculator and you'll get the right answer. So as long as you type 6 times 7.42 divided by 100 plus 7 times 92.58 divided by 100 and then it equals, you will get the correct answer. Okay, so let's see what your answer should look like. So if I erase this for you all, okay? And now I look at what is given for the 2 parts. If you put it into your calculator, you should get 6.9258. Okay, we don't necessarily want to leave the number like that. It just becomes too many digits. So just like when we did molar mass, and every time we take that mass from the periodic table, we're going to round it to 2 decimal places. So if it's 6.92 and then there's a 5 after it, we just round it up to 6.93. And for all of these, because we're talking about the mass of an atom, the unit is always going to be AMU. Okay, and that's it. That's all you have to do. So it should be nice and easy. Just use the information in the question, put it into the formula, solve it with the calculator the way it's kind of written out, round it to 2 decimal places, and then put a unit AMU on it. Okay, so let's try the next one. All right, so in this one, example 2, fluorine has 3 isotopes. F18, F19, and F21. F18 occurs 10% of the time, F19 occurs 86% of the time, and F21 occurs 4% of the time. And then they want you to calculate the mass of fluorine. Okay, so we're just going to do what we did just a few minutes ago. So if we start with the first mass, that's F18. And F18 occurs 10%. Okay, so we use the mass because this number is our mass number. This is our hyphen notation. So the number after the dash, which is called your hyphen, is your mass. So we're going to use the mass, which is 18. We're going to multiply it by our 10 and then divide it by 100. Okay, first isotope done. But again, at the beginning, they told you there's going to be 3. So we already did 1. We got 2 more to go. Next one, we have F19, which is 86. So we do 19 times 86, and then we divide that whole thing by 100 as well. 2 isotopes down, we got 1 more to go. So we add 1 more time. So now we got this 21, which is 4%. 21 times 4, and then we divide that by 100. Equals, and that should give us the right answer. Okay, so I'm going to erase this, and then we'll see what the actual answer is, if it'll cooperate with me. There we go. Okay. And there's our first one, our second one, and our third isotopes. When we put it in our calculator, you should get this answer, which is handy and nice because it was already rounded to 2 decimal places, and then you just put the unit AMU on it. Okay. All right, let's do the final example. This one is a little bit harder, okay? If you notice, it's all on a table for you. They're telling you you have 2 isotopes, isotope number 1, isotope number 2, okay? Now, what you typically need for average atomic mass, since that's what they're asking you to find in the question, is the mass. I don't see the mass anywhere. But notice I put a red box around protons and neutrons. If you remember, the mass of an atom is always equal to the total of your protons plus your neutrons. So all you have to do is add these 2 numbers together to get the mass. So for the first one, 120 plus 150, that's going to be a mass of 270. And if we do the same thing for the second one, just to have the number ready, 120 plus 155 is going to be our 275. Okay, so now that we have our masses, they already gave us the abundance percentages. We just put it into the formula. So the mass of the first isotope is your 270. We're going to multiply that by 78, divide that by 100. We're going to add that to our 275 isotope mass times the 22 and divide that by 100. Really, that's your setup right there. So then you could put that into your calculator and hopefully get the correct answer. And this is being finicky, so I don't know if it'll let me erase, which is fine. Okay. All right, so then your answer, if you did it correctly, you should get 271.1, which if you follow what we've been doing and make it 2 decimal places will be 271.10 AMU. Okay. And that's all there really is for average atomic mass. So go ahead and work on the practice classwork for that, the front and back. And then when you're done, you can check your answers on Schoology. Thank you very much.